We've talked a lot about talking about motion, and now we're going to talk about specific motion for objects that are dropped or thrown, because there's some assumptions that we can make if we know that something was thrown or if it was dropped. So an object is said to be in free fall if and only if gravitational force is the only thing pushing or pulling it. So if something is in the air, there's nothing holding it up, there's no parachutes attached to it, it's just freely falling under the gravitational force. It's being pulled on by the earth, then it's in free fall. If I throw something in the air and it's traveling upwards, but it's slowing down because the gravitational force is pulling down on it, it is still in free fall. The only time it wouldn't be in free fall is if we're finding some other force that we know is pushing or pulling on that object, aside from the gravitational force. All objects that are in free fall have the same constant acceleration g, which we will call the gravitational acceleration. So if something is in free fall, by definition, its acceleration is equal to g, which is equal to 9.81 meters per second squared, while close to Earth. And we can assume that all of our problems, until I say otherwise, they're close to Earth. So you can always use g is equal to 9.81 meters per second squared, or if you prefer, g equals to 10 meters per second squared is close enough for this class. It makes the math a little bit easier, but the reason I do like using 9.8 or 9.81 sometimes is it helps make sure that I'm not making mistakes of, if you use 10, sometimes your numbers round and you might think something to be true that's not. But either one is totally fine to use for this class as long as you clearly label and make it apparent which one you're using, either 9.8 or 10, whichever you're preferring. Both of those are the gravitational acceleration. And again, all objects, it does not matter if they're heavy, light, big, small, they all have the same gravitational acceleration. The reason that when, say, you drop a piece of paper and drop a rock, that the rock falls faster than the paper is because we're not assuming free fall there. There's air resistance that's slowing down the paper. So yes, in the real world, there's always air resistance. But when we're talking about it in physics, we're going to deal with a lot of oversimplifications because either the air resistance is minimal and therefore we can neglect it, or we're just trying to get a feel for it. Or it might be in a vacuum chamber where there is no air resistance. Projectile motion is a special term that we give for the motion of an object in free fall. So an object, if it's in free fall, we can say it's undergoing projectile motion. And this is usually because we're talking about something being launched. We're talking about a projectile and that kind of parabolic motion. That is described by free fall, but technically speaking, it's the broader term. Usually what you'll see is if something is just moving vertically, or if we're talking about something being dropped, you'll tend to see free fall. If something is launched, or it's moving in 2 dimensions, that's where you'll tend to see projectile motion. But if you use one in place of the other, you will be fine. They can be used largely interchangeably. That will wrap us up here with free fall and projectile motion.